welcome back to my YouTube channel. Let's crack real math. My name is Viraaj, and in this video we'll be having a look at reflection under the topic transformations. So before we begin the video, please do not forget to perform an LSS, that is like, share and subscribe, and without further ado, let's get started. So before I go into some examples, let's actually see what we mean by reflection. So just a second. Okay, so as the name suggests, reflection is simply an image or a shape reflected, that means produced in the same manner but in a different place. So what I mean is, let's have a look at this graph here. Suppose, of course in mathematics, suppose that we have a shape. Let's say we have a triangle somewhere here. It goes like this, then goes like this, and then goes like this. And I'm told to reflect this triangle. So whenever I am told to reflect a certain shape, they will give me a certain rule. So they would say, reflect this image in the line. So that line is essentially the most key thing. So if it says to me to reflect the image in the line y equals to 3, I know that y equals to 3 is this line over here. Yep, something like that. And all I have to do is just take this image that I have, or the shape up here, and reflect it onto the other side. And how I would do that is I would just count from the 3 vertex over here. I would just count the amount of spaces it would take for me to reach to the line. So in this case, 1, 2, 3, and then count the same amount of spaces on the other side of the line. So 1, 2, 3, and mark that 1 point there. Same thing for this vertex over here. So 1, 2, 3, 4, 5, 6. And you count 6 again. 1, 2, 3, 4, 5, 6. Mark it over here. And the same for this one here too. So 1, 2, 3, 4, 5, 6. And then 1, 2, 3, 4, 5, 6. And mark it somewhere here. So essentially I would have something like this as my reflected triangle. So simply you can think the line that they give to you, which in this case is y equals to 3. This is sort of like your mirror, the mirror at which you have to reflect. And then you just simply count the spaces from each vertex to the line, and then from that you count the same amount of spaces and then plot the point. So let's have a look at the first example. Right, so this question tells me to reflect the following shape in the line x equals to 7. Now the first thing you should do whenever you are reflecting is take note of the line. It says x equals to 7. So let's quickly get that line, draw that line. So the axes are not labeled, so we can label them. We can say, okay, this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, 7. Note that it said x is equal to 7, so we are working with the x-axis. And now x equals to 7, we know, is simply something like this. Trace it all the way up to there, okay? And we know that this also extends to the bottom, into the negative part. Okay, so now you now have to take a look at our shape, and all we have to do is reflect it to the other side of this line. So again, let's take a few vertices. Let's take this point, let's take this point, let's take this point there, let's take this point, and then we can see if we need more points just to be on the safe side. So let's have a start look at this one. So from here to the mirror line, which is x equals to 7, we know we go from 1, 2, 3, 4, 5 places. So from here we go 1, 2, 3, 4, 5 places. This is where our first point is. Let me just erase all of this to avoid confusion. Right, now let's take a look at this point here. to the mirror line, we go 1, 2, 3, 4, 5, and then from the mirror line we go to 1, 2, 3, 4, 5, somewhere there. Now let's have a look at this point here. Now as you can see, this is not exactly 2 whole units. We know it's 1 whole unit and maybe 1.8. So we need to go 1.8 to the other side. So let's zoom in a bit actually. As you can see, this is not completing 2 whole units there. So we know there's 1 whole unit, that's all of this, and 0.8 of this. So that's 1.8. And going 1.8 over here should end you up somewhere there. Okay, now this is not exact, but it's enough to give you the rough sketch of what we're trying to do. Please do make sure that in your exam you are as exact as possible. So done with that one. Now let's have a look at this one here. And this one is a bit below here, but we can see that goes 1, 2, 3, 4. So we go 1, 2, 3, 4, somewhere around about there. And now we can see that the image is forming, but let's just take another point just to be on the safe side. Let's take this one. This one goes 1, 2, 3, 4, maybe even 4.1 because it is a bit extended, but we get the idea. So 1, 2, 3, 4. This is somewhere here. Right there. And now we can connect the points, but let's just have a look at this one too real quick. We know it's 2 whole units, but not exactly 4, 3. So this would be 1, 2, and most likely somewhere here. Yep. So now if we connect all our points together in the way they're meant to be, like that, like that, that, okay, let's do that one again. No, something like that, and that is how our shape is supposed to look like. Again, it doesn't look the most accurate, but I think this is most likely to be correct and is looking correct as well. But please make sure that in your exam you're as accurate as possible with your drawing. On to the next example. This one tells me to reflect the following shape in line y equals x. So our mirror line is y equals x. We know the mirror line y equals x is something like this. It goes through the origin and divides equally between the two, so that at whatever point you intercept the line, y and x are always equal. So let's just do this on this side too. That should be good. So now all we have to do is reflect this shape over here into our mirror line, which is y equals x. And to make it easy for us, what we can do is we can take 4 points, 4 corners, or 4 vertex from the shape. So we can take this one, this one, this one, and this one. Now a lot of mistakes students make is that when you are trying to reflect in a line that's not exactly straight, not vertical, not horizontal, as you can see this is slanted, they go like this. They would count, so 1, 2, 3, 4, 5, 6, and then reflect 1, 2, 3, 4, 5, 6. This is wrong because you're not meant to go left to right, because it's not an exactly vertical line. You're meant to go the closest way you can go to the mirror line. So in this case, instead of going like this, you will go something like this. So you'd go, okay, 1, 2, 2.5. That's what you would do. So let's do it that way. Let's just erase this. So taking a look at this point over here, we go 1, 2, 2.5. So we now go the half, the 1, and the 2. So this is somewhere where your shape is meant to be. That's the first point. This 1, 2, 2.5. Yep. Okay. Now let's have a look at this corner here. This is, you could say, it goes 1.5 over here, and again it goes a half over here. So somewhere there. Okay, no, just a second. It goes from here to here. Okay, so right, this would be, this point here would be somewhere here. Again, not the most accurate, but we get the idea. Let's have a look at this vertex here. It goes 1, 2, 3, 3.5. So 1, 2, 3.5, somewhere there. Let's confirm 1, 2, 3, 3.5. 1, 2, 3. Yep, that is it. And the final vertex, which is this. This goes same way. 1, 2.5. So half, 1 and 2. So somewhere there. And if you connect all these points together, you should have something like this. Yep. Again, not the most accurate, but I think we get the idea. This is how your shape is meant to look like after reflection in the line y equals to x. And that is the answer to that question. And on to the final one. It says, reflect the following shape in the line y equals to x minus 1. Now, before I start attempting this question, please, if you have not watched my video on drawing straight line graphs, you may want to do so, because this question will be made a lot easier if you know how it is written. Now we know y equals x minus 1 can be compared to y equals to mx plus c, where c is your y-intercept, that's minus 1. So let's go to the graph and get minus 1, that's minus 1 here. And your m is simply the gradient. That's basically the coefficient of x, which in this case is 1. Since there's nothing in front, we know that represents 1. So the gradient is 1 at all times. So we know that it will now go somewhere here. So basically, before I start attempting the question, you need to make sure that you know where your reflection mirror is, your reflection line is, and that's what we're trying to get over here. So if I now just get these points together, go something like this. Since there is a gradient of 1 only, so we'll always go past at a proportional rate, something like this. Let's go to here. Yep, that looks most accurate. Y equals x minus 1, y minus 1 over here, because that is your y-intercept, and your gradient is 1 at all times. Now again, we can look at take 3 points, 1, 2, and 3. So let's start with this point over here. We know that. Now another thing I want to say is, as I said before, the mistake students would make, they would go from left to right. They would go 1, 2, 3, 4, 5, 6. But that is wrong, because it's not a vertical line, it's a horizontal. It's not a horizontal line, it's a slanted line. So you need to go the closest way possible to the mirror line. So you'd go 1, 1, 2, 3, and go 1, 2, 3. So that's where your first point would be. Let's erase these two. Yep, there. Now let's have a look at this point over here rather, sorry. If I were to go from this to the line, I would go 1, 2, 3, 3.5, 3.5, yep, and then I'd go 1, half, 1, 2, 3, so somewhere there. So I got the half from here, and then 1, 2, and then the final 3, because it came from half, 1, 2, 3, all the way there. And the last point, which is a bit interesting because this is already on the other side of the mirror line. So now you may be wondering, well, it's already on the other side, what do we do? The answer is that you have to reflect it no matter what. So you still reflect it this time to the other side. So it's a half over here, will now be a half over here. So a reflected image will now look something like this. It's your thing, that's there. That is connected right there, and that is your answer to that question. Again, it's not the most accurate, but I think it is sufficient enough to be deemed as correct. Now, one trick that I would give to you is, again, the question where how do you know how many spaces to count and in which direction. Now again, most people, if I was to take this point as an example, they would go this way, but that is wrong. One trick you should know is that whenever you are counting the space, they should be at a right angle to the mirror line. As you can see, if I were to draw a line from this point here to all the way this point to where I was counting, you can see there's a right angle being made. Similarly, if I was to take this line here and make a right and go straight with it to where I was counting, again you can see somewhere there a right angle is being made. So you need to make sure that right angle is being made when you are counting your points. So that brings us to the end of the video. Thank you for watching, guys. Hopefully you enjoyed it. Please do perform an LSS, that is like, share and subscribe. And thank you for watching. Have a nice one, guys.